Welcome. In today's topic, we will learn how to write the names and chemical formulas of covalent compounds and also how to correctly identify the covalent and ionic compounds so that you can accurately apply the specific rules for each of them. So let's start the topic. Covalent compounds. As the name says, the covalent. So if we break this term down, so co means common, valent means valence electrons. So these are the compounds that are formed by the atoms when they keep their valence electrons in common, means they share electrons. So that's why it says these compounds are formed by sharing of valence electrons between the non-metals. Very important. So covalent compounds are formed by the bonding of non-metals only. Metals don't make covalent compounds. All right, keep that in mind. Other thing is what valence electrons are, just in case if you are wondering. So I have already covered that in another video, so make sure you do watch the videos shown up here in the cards. So valence electrons, otherwise briefly I can touch up. So these are the electrons present in the outermost shell of an atom. So when the valence electrons are shared between the nonmetals, so that's how the covalent compounds are formed. Some examples are, of course, a very common molecule we have here is oxygen, right? Of course, everyone might have heard about this. Carbon dioxide, very familiar molecule. How about water? Water, ammonia, chlorine, all these are covalent compounds. Other than that, there are many other covalent compounds. And because most of the ionic compounds, they are free independent molecules and most of them they exist as gases, so that's why covalent compounds are normally called as molecules as well. So molecules, and also they're called as molecular compounds. So molecule word or molecular compound word is very common to use for the covalent compounds. All right. Now, the rules to write the names and the formulas for covalent compounds is literally very easy. There is nothing hard. Why? Because, first of all, no charges. You are not supposed to take care of charges, right? Like you are in in ionic compounds, we do need to take care of the valency, charges, crisscross. No need of polyatomic ions. No need of Roman numerals, no need of multivalent atoms, right? Multivalent metals that we have learned in the ionic compounds naming. So covalent compounds naming or formula writing doesn't need any of that. The only thing is the writing is very simple, but the only thing is that you need to understand the difference between the covalent and the ionic compound. If you mess up identifying the given compound or the name, then chances are you might mess up. All right, so let's just quickly go over how the covalent compounds they look different from the ionic compounds. Okay, something very important. In ionic compounds, you will see some positively charged species bonded with the negatively charged species. So typically it will be some metal with non-metal, or it could be polyatomic cation. I have already explained everything in my other video, naming of ionic compounds. So polyatomic cation that we can have is just the ammonium ion, right? The only one polyatomic cation we have is ammonium ion, or it can be sometimes a hydrogen ion present as well. So if any of these is present along with any of non-metal or any of polyatomic ion, then it is ionic compound for sure. So either with non-metal or with polyatomic ion. Covalent compound, very easy to identify. Covalent compounds will have only non-metal and non-metal bonds. So you will only see non-metals in the covalent compounds. Okay. So no metals, no positively charged species, no polyatomic ions, All right, so covalent compounds are very easy to identify. Okay, other thing is, if I just give you a quick sum, let's practice a little bit of that. So how about, as we already did, NH3 and NH4Cl. Could you identify which one of these is ionic and which one of these is covalent, or maybe both of them are the same? Try it out. Okay, well tried. I hope you figured this out, that this is covalent compound. This is covalent, and I'm very sure you might not have messed up. This is ionic compound. Okay, you might say, if you didn't get it right, you might think like, oh no, it does have nitrogen, does have hydrogen, does have chlorine. All of these sound like non-metals, right? There is no metal here. Then why it is ionic compound? Then don't forget, what did I say? Ionic compounds, they can start from ammonium ion as well. So NH3 is a molecule. This is called as ammonia. The name for this molecule is ammonia. And NH4 is ammonium ion. A lot of students I have seen, they mess up with these two in the beginning somewhere, right? Later on, of course, with practice, you will learn everything. But ammonia, NH3, pure, it's a covalent compound, I mean. And NH4 is NH4Cl, NH4NO3, NH4, whichever, whatever starts from NH4 is always a ionic compound. Okay, I hope you got it. Let's try one more example. How about NCl3 and VCl3? So try it out. Think for a minute. If you're done enough thinking, let me help you out. VCl3, I hope you figured it out correct. VCl3 is ionic compound, right? And NCl3 is covalent. Obviously, this should be, I think you got it right. V is vanadium. Vanadium is a transition metal, right? It is a metal, at least. You should know that. It's a multivalent metal too, if it is transition metal too, but at least you should know it is a metal, right? So metal with non-metal has to be ionic. Nitrogen is non-metal, chlorine is non-metal, so of course non-metal, non-metal, this is covalent, ionic, right? So I hope that helps you out. So if you identify that the given compound is a covalent compound and you're not messing it around, so then applying the rules for naming and to write the formulas is very, 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 very easy. So let's move on how to write down the formulas and the naming. So very simple rules we have to follow. Rules to write the names and the formulas of the covalent compounds. First thing first, when we write the names of the nonmetals, so the first nonmetal will always be written with the same name as you find from the periodic table, means the nonmetal on the left side of the molecule, and the nonmetal on the right side of the molecule will end up with IDE. So same way, like we convert the right side nonmetal in ionic compounds into ide, same way we do that even in the covalent compounds as well. For example, let's say if I have, for example, I have SO2, so we'll say it sulfur as it is from the periodic table. O means oxygen. So oxygen will convert to oxide because oxygen is on the right side of this molecule, right? So whether if it is oxygen or any other whatever non-metal it is, we will convert it into ide. So if it is chlorine, chloride, bromine, bromide, sulfur, sulfide, phosphorus, phosphide. So likewise, so any non-metal on the right side of the covalent compound will end up with IDE instead of the actual name written on the periodic table. So keep that in mind. We'll of course do the full name, how to write down in the next slide. Other important rule is we do use prefix. All right. So how many numbers of, because here we are not going to specify the charges or the valencies, we don't need to do that, but we need to specify how many number of atoms of each element are present in the given covalent compound. So we'll use prefix to specify the number of atoms. So like for example here, sulfur is only one of them. So one sulfur is there and there are two oxygen present. So if there is one sulfur and if there are two oxygen present, I need to specify how many sulfur are there, how many oxygen are there. Okay, but don't forget to read this rule as well. The first element, if it is single, we are not going to use mono with that. Mono is a prefix for single atom, for one atom. So sulfur is single here, so I will not write mono sulfur. That's wrong. Okay, but I'll just write sulfur. So if the first element is single, we don't need to specify that with the prefix. Keep that in mind. So this is what is the exception here. So we do use prefix to specify that. For example, here I have two oxygen, so I will have to write dioxide. Why? Because sulfur trioxide is also possible. Sulfur trioxide also exists. So I have to specify how many oxygen atoms are there. So 3 tri. So I will say 3 sulfur trioxide. Here I will say sulfur dioxide. But if the first element is single, then I don't need to specify it with mono. But just to consider another example to see where we do use mono is, for example, if the second element is single. Let's say if I have NO, again nitrogen and oxygen means it is covalent compound, we are sure. So nitrogen, we'll just simply write it as nitrogen. We are not going to specify it with mono. We don't need to write mono nitrogen, but we will write mono oxide like this. All right. Like same way, we'll have so many examples actually after in the next slide. Let's quickly go over the next rule. So while writing the chemical formula, never reduce to the simplest whole number ratio. Oh yes, that's very, very important. If you remember or if you have watched the video for ionic compounds already, we know that ionic compounds are always written in the simplest whole number ratio. We have to reduce the ratio. Just a quick example. Let's see if I have, for example, if I have Mg, because magnesium when it will bind with oxygen. If you are not getting this, what I'm talking about, you can watch the video of the ionic compound. You will understand what I mean. So magnesium, let's see if it bonds with oxygen. So magnesium has positive 2 valency, oxygen has negative 2 valency. We crisscross the valency, so the formula comes out to be like Mg2O2. But now this is not the right name. So we'll write MgO because 2 and 2 will be simplified to the simplest whole number ratio. But now in covalent compounds, let's say if I have N2O2, I cannot write it as NO. This is different. This is a different compound. So N2O2, if I have, I will write down its own name. So I'll say di, because there are two of them, nitrogen dioxide. So what is important to keep in mind? Never reduce the covalent compounds atoms into the simplest whole number ratio. Leave it as it is because all of them, they are different compounds, different properties, different names. All right. So this is again another important rule to keep in mind. Now, homoatomics, we don't use prefixes with the homoatomics, especially with the diatomics. I will teach you this rule at the end of this video, so stay tuned. So first of all, let's just talk about rule 1, 2, and 3. Okay, so as we are already working on the names, so let's continue with the naming first. So this is the list of prefixes we're going to use. So just in case, mostly it is provided in the quizzes or in the exams. If not, if this list is not given, you can just simply memorize it because this is pretty much very useful in the organic compounds naming as well. You will be learning later on somewhere in chemistry. So these are the prefixes we will use to specify the number of atoms. All right, for example, CO, CO2. I think you understand already what I'm trying to say. So CO, are we going to use mono with carbon? No, because as I said, the rule, second rule, if you remember, we don't use mono if the first element is single. So I'm not going to say monocarbon monoxide. Instead, I'll say carbon monoxides. All right, carbon monoxide. And for CO2, it will be carbon dioxide. So I think it's pretty good. All right, clear? Mono to be used when the second element is single, mono not to be used if the first element is single. All right, and yeah, so don't forget that if it was oxygen, so I'm converting it into oxide, then it's ending up with oxide, right? So if it is, for example, PCl5, PCl5, I'll write it down as phosphorus. Phosphorus here stays as it is again because it is the first element here. So second is chlorine, so phosphorus chloride. How many of them? We forgot. It's penta because 5 of them. So I'll write phosphorus pentachloride. Clear? Similarly, if I have, let's say, N2O4, again, we are not going to reduce it to NO2. That's wrong. NO2 is a different compound. NO2, different properties, different nature, different molecule. So if it is NO2, we'll write down the name differently, right? So NO2 is a different compound. So N2O4, we'll write dinitrogen because di means 2 of the nitrogens are there, 4 of oxygen is there, so tetra oxide. Clear? NO2 will be definitely ending up with a different name, so it's a nitrogen, no mono, simply nitrogen dioxide. So I hope that clarifies how to write down the names of the covalent compounds. All right. Now let's work on, if the name is given, how to write down the formulas of the compounds. So when we write the formulas of the compound, again, this is very easy. For example, dioxide we did. Let's say if it is giving trioxide, so we will write sulfur as it is, the symbol from the periodic table, S. Tri means 3 of oxygen is present. So oxygen oxide, of course, means oxygen atom. Symbol is O. Tri means 3 of them. So SO3, sulfur trioxide. If it was sulfur dioxide, I will do SO2, means 2 of oxygen. So here we don't have to crisscross the valencies, charges, we don't have to take care of that. So what we need is, we just need to see what prefix has been used. And again, the same rule, if the first of the element, the name of the first element does not come up with any symbol, that means it's just one. So if it was disulfur, trisulfur, that means we will have used 2, 3, 4, whatever here along with. But here it doesn't say anything, that means it's just mono, means it's single element. So I'll just keep it as sulfur dioxide means SO2. All right. For example, if I am given diphosphorus pentaoxide, so di, the prefix list we have done, di means 2. What is there? Phosphorus means 2 of phosphorus. So how would I write? A symbol for phosphorus is P. Di means 2 of them, so I'll write 2 of them. And pentaoxide, penta means 5 of, oxide means oxygen. So P2O5. Clear? So these subscripts here in the covalent compound specify how many atoms these how many these non-metal atoms are present in the molecule. Simple as that. For example, if I have SF, if the name is given sulfur hexafluoride, sulfur S, hexa means fluoride. It doesn't say sometimes students also confuse here with hexa coming with sulfur. No, hexafluoride means Fluoride is hexa, means the 6 of the fluorine. So we will write SF6. If it was tetrafluoride, we would have written SF4 means tetra. Alright, so like that. So this is how we write down the formulas if the names are given. So just very simple, nothing complicated. We just have to find out the symbol from the periodic table and find out the prefix used in the name. So we'll just specify that, and that's how we will just write down the formula. Just write out, for example, I have carbon disulfide. So can you try out by yourself? If you're done, so carbon, you must have written C, sulfide, S. There is no symbol, sorry, no prefix with carbon, so that means only one carbon is there. Disulfide means there are two of the sulfur, so CS2. If you did this right, way to go. Good job. So let's move on next. So here we will apply the last rule, and that's very specific for the homoatomics. Homoatomics, like means the atoms they bond with each other with the same atoms. So like for example, I say H2, O2, N2, F2, Cl2, Br2, I2, P4, S8. So all of these elements, but in all of these molecules, what is special? That same atom is bonded with each other. This is list of some homoatomics, right? So hydrogen bonded with other hydrogen. In this molecule, oxygen is bonded with other molecule. In this molecule, nitrogen is bonded with other nitrogen. So just in case if you are wondering why I'm drawing these one line, two line or three lines, so this is called a single bond, double bond and triple bond. So I'll be just covering this up in the next upcoming videos. So basically what you need to notice here is that the same type of atom is bonded to each other. Before, what we have done in the other previous all the examples, there were at least two different non-metals bonded to each other, SO2, CO2, H2O, like that. So here we have two same atoms bonded with each other. So these are called as homoatomics. So homoatomics means same atoms bonded to each other. Of course, covalently, because metals are not going to bond with the metals. The atoms are bonded to each other, of course, the non-metals, right? Non-metal atoms. So when the non-metal atoms, same non-metal atoms, they bond to each other, that is called as homoatomic. So their name is a little different. Not hard, but only thing that you have to keep in mind, for all of these, we will not write, even if you see two, let's say two of the hydrogens. Are we going to write it as dihydrogen? No, we'll just simply write it as hydrogen. So we don't use prefixes with the homoatomics. I'm not going to write dioxygen, dinitrogen, difluorine, dichlorine. So usually I will say, most of the times we'll just simply say hydrogen gas, or just simply say hydrogen. So if it is existing as a molecule, I'll just simply say hydrogen or hydrogen gas to be specific. Oxygen, I'll just simply write oxygen gas. All right, so hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine. Actually, all these are gases. Let me also specify that. But bromine exists as a liquid at room temperature, so we'll not say bromine gas. Iodine exists as a solid at room temperature. So other than that, all these exist as gases at room temperature from here. Hydrogen to chlorine. So these ones we will say that these are gases. So if you want to specify, we can say nitrogen gas, for example, right? Otherwise, just simply nitrogen. Fluorine gas or fluorine, chlorine gas or chlorine. So in the chemical reactions, we will be talking about in the next upcoming video somewhere. So in the chemical reactions, let's say if I say some element reacts in the presence of oxygen. So that means you will write the name of that element reacts with in the presence of oxygen means you will write it O2, not as a O, right? This is what where it will be really helpful. All right. If I say some element or some molecule reacts with in the presence of nitrogen, so you will just write N2. Fluorine in the presence of fluorine means F2. So we will not write single elements. All right. So these always exist as um, homoatomics. The first seven you see here in the list is they are called as diatomics. These ones: hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. These ones are specifically called as diatomics. Why? Because only two atoms are bonded to each other in these ones. You might have noticed already, right? So these two are simply homoatomics. They are not diatomics, but because there are more than two atoms attached, so we can't call them diatomics. But still, we don't specify their prefixes either. So we'll just simply call it as phosphorus will be just simply phosphorus. This is not going to be, most of the times they will not say, no one is going to say mostly tetraphosphorus. We'll just simply say phosphorus. So if I say phosphorus reacts in the presence of oxygen, so how will you write it down? Phosphorus means, this is understandable that phosphorus exists in nature as P4, so P4. Oxygen exists in nature as O2, O2. So whatever they make, that's a different story we'll cover up in the chemical reactions video. But here I'm just teaching you like what is the purpose of writing these as it is. So if I say sulfur, so I'm not going to say octasulfur, simply this is sulfur, right? So these phosphorus and sulfur, they do exist as solids at room temperature, of course, right? And these diatomics, as I said already, so most of them, they do exist as gases, bromine as liquid, and iodine as solid. So what is special about the homoatomics? We don't write the prefixes, right? Other than that, so let me just write it down quickly. We don't write prefix, right? Other than that, now we have next something very important. There are some molecules that are very common in nature and they're very common in daily use as well. So we use their common names most of the times, right? So I'll just give you a quick list for some of them. So like for example, NH3, for example, H2O. So NH3 will be, generally if we write it down following the rules of the covalent compounds, it should be nitrogen trihydride, right? This is not wrong either. So this H2O should be dihydrogen monoxide. These are not wrong, but most commonly we use them, we use their common names actually. So the common names, just in case if you want to note down. So NH3 is commonly called as ammonia. So you will usually see in the books, like even in the reactions or in the questions, the titration. So anywhere, wherever the chemistry. So we're going to use the name ammonia most commonly. H2O is called as water, right? So similarly, CH4, we can write it as carbon tetrahydride, but it's not written as carbon tetrahydride usually. So because it's again a very common molecule, we'll just simply write it as methane. Of course, this is specifically an organic compound, so this is more specific name. We'll learn when we learn actually the naming of organic compounds. Right now, you don't need to bother about it. So methane is most common name for CH4. Other than that, it can be PH3. This is called as phosphorus trihydride. I think you are understanding the naming now. So PH3 will be, it's most commonly called as phosphine. So you will usually see this name better. So other than that, I already gave you, these are some of the examples, but in addition to this, we have already done the 7 diatomics. So those ones we just simply use the name of the symbol, like hydrogen, nitrogen, and oxygen, fluorine, chlorine, bromine, iodine, like that. Phosphorus will be P4. So we'll just keep it as P4. So I hope you understand The difference between the ionic and covalent compounds, how to identify. Of course, there are a lot more differences. I am going to cover up how the ionic and covalent compounds are formed and their properties like in separate video. But here, I hope you have learned already how to write down the names of the covalent compounds. Now, I am going to give you some practice questions here. So you will be writing down the answers just to see how well did you got the concept. And I will be also posting the answer key to those questions. So if you're doing this all well, so that means you're good to go. So now you can pause the video here and try out these questions. Once done, so I have the answer key next. All right, so take your time. Answers to all the questions. I hope you got it right. If not, then you can ask me any questions or concerns in the comment section. So I will try to reply as soon as possible. So hopefully this helped. So if you really like the video, so make sure you do subscribe to the channel for all great upcoming content regarding chemistry and biology, AP and IB subjects, MCAT, and a lot of other competitive exams. Stay tuned. All right, thank you.